Well, I want to welcome everybody here, all of you, to the Repair and Maintenance Summit. I'm Vince Marino, your host. I've been working with Empowering Pumps for about 5 years now, a little more than 5 years. And I got a genuine interest in learning and sharing recorded content. I believe that people that are in the pump, motor, valve, seal, vibration, all kinds of worlds need repair and maintenance information, and I'm coming to you to share. So I want to say thank you for hopping on the Repair and Maintenance Summit. I'm looking forward to it. And what I'd like to do, if it's possible, is and we're going to start with Greg and just kind of toss it to the next person. Greg, let's just tell your name, your company, and the role you're in repair and maintenance.
Thank you, Vince. Good morning to everyone. Hope this finds you doing well. My name is Greg Bell. I currently work for Hydro Inc., which is the largest independent service provider for rotating equipment across the globe. Just a little bit about me, right quick, is I was a 27-year reliability specialist for Chevron's Port Arthur refinery, over about 4,800 pieces of rotating equipment. I elected to come on board on the aftermarket side of things, kind of the other side of the spectrum, if you will, with Hydro, to bring that customer end user experience and view of our service providers to the industry. Kind of did that with Hydro, been with Hydro now starting my 18th year. So between 44 and 45 years of rotating equipment experience is where I've spent my entire career. And again, our goal is to provide quality services through reliability, testing, training, repair, condition monitoring, numerous areas that Hydro can approach the customers with helping them to run their equipment more efficient and try to increase their mean time between failures and not have any unplanned outages. So just a brief background and overview of myself. Sebastian?
Thanks, Greg, and thanks, Vince, for having us on. We appreciate it. It's great to be here. My name is Sebastian Traeger. I serve as the CEO of Reliability Center, or reliability.com. And our company has a 40-year history really focused on one thing, and that is doing root cause analysis with excellence. We help companies with training and with software. We have a product called Easy RCA that we think is the best in class RCA tool on the market. So yeah, that's really what our company does and how we help people. And we appreciate being here, being able to share our story, and hopefully just help others out there who are facing problems and looking for solutions.
All right, thank you. Let's toss it to Jake. Jake?
Yeah, thanks for having me. I work in marketing for Curflow with Paul there. So, from running social media accounts to email campaigns to tracking data and communicating with our distributors. So, glad to be on. There seems like there's a lot of experience on this call, so I'm looking forward to learning as well. And thank you for having me.
Excellent. Adam, how about it?
Hey, how you doing? My name is Adam Stretto. I'm a mechanical engineer with Ludeca. I'm going on 15 years now, next month. 18 years total working with rotating machinery. But here at Ludeca, we have precision measuring devices for rotating machinery and predictive and remote technologies for machinery and industrial reliability.
Okay, how about it, Brian?
Hey Vince, how you doing, everybody? My name is Brian Bieshke. I'm the head of community and partnerships for Upkeep, a CMMS provider in the space. I have 20 years experience as a heavy equipment mechanic and naval veteran, a heavy machinery repair technician. Been a maintenance manager, director of maintenance and reliability. Have led several departments, statewide, multiple state programs. Yeah, so I do all the expert consultation and connection to industry for Upkeep as a CMMS company.
All right, let's toss it to Bob and then to Paul. Rob?
Yeah, Rob Dotson, Chief Product Strategist here at ImproSeal. Recently came back to ImproSeal after 15 years in various other industries and companies. I guess my 30 years experience in reliability has been a quilt, working across the form from rebuilding equipment to installing equipment to monitoring equipment, keeping it maintained, and then coming up with ways to keep it reliable. So excited to be part of this group, excited to be part of this forum, and looking forward to sharing and learning, as Jake mentioned.
How about it, Paul?
Yeah, and I'm Paul Yapel. I'm responsible for sales and customer service at Curflow Pumps. We are, I'm going to say, the premier provider of aftermarket pumps and spare parts and accessories for a lot of the most common pump types out there in industry. So we get involved in a lot of rebuilds and replacements and a lot of this reliability stuff as well. And very interested to see what everyone's got to say.
Great. Let's start with Paul on that. So, Paul, what are some of the most common maintenance challenges that you encounter in your industry, the industry that you serve specifically, and how do you recommend addressing them?
Well, I think that I'm going to say the biggest issue we see with reliability is understaffed maintenance and reliability crews at the plant level. Like we see so many of these places that, years ago they had a pretty full team and had a lot of people looking at this stuff, and now we see those teams getting shrunk. So there's fewer eyes on equipment, fewer eyes on reliability. There's less money to be used in terms of trying to do that stuff. So I'd say that's probably the biggest challenge that the equipment owners face, is that they just simply, they don't have the time, they don't have the manpower, and they probably in a lot of cases don't have the knowledge that they at one time used to have long ago. And I would say then the best thing that they can do is look around at this group and pump distribution and like the pump specialty houses that really understand this equipment, that have sort of expanded into that space and has taken up a lot of the slack out there in terms of really understanding the equipment, how to make it reliable, how to tell if you've got issues with reliability or an upcoming issue, and really lean on sort of third parties to do a lot of this. I think is probably the best strategy out there currently.
Adam, can you chime in? Again, the question is, what are the common maintenance challenges that you encounter? Ludeca specifically has alignment and great products. So, in your specific realm, how do you recommend addressing these common maintenance challenges that you encounter? And then let's toss it over to Rob, and then up for conversation among the team.
Okay. So one of the challenges I see is that failure, that early failure during the infant mortality period, right? And I think it's because, kind of piggybacking off of Paul is not only the lack of people, but not having enough people is not allowing to doing the job right the first time, And so, not doing proper installation, checking your base plates, doing precision alignment, right? Or, even establishing a baseline of what does that machine look like when it's good, right? Right at the beginning, right from commissioning. And I feel like if we started doing that, we can at least know where the machine is in good shape. That way we can kind of trend from there as to see where it's going to fail and try to catch it early, and allow our short staff to focus on failures that are that we react to instead of something we can plan for.
Okay, Rob, how about it on your end?
Yeah, I think I'd have to piggyback on Paul and Adam. From a standpoint of manpower, we see manpower continuing in the maintenance realm and reliability realm to continue to shrink, right? The experienced people. From our standpoint, creating seals for difficult conditions and environments, it really is about understanding what that equipment is going through and what it needs in order to operate. To Adam's point on alignment, right? Are you aligning to a hot target because you're in a hot environment and you have a big change in thermal change between the pump and the motor and the process? All of those conditions create stress on a system, and it's being able to identify, having the people in the plant to identify that and be able to look at, what's needed. Is it a seal? Is it routine alignment? What can be monitored to know when that piece of equipment is stressed? And so all of those pieces come together to create a maintenance program. And again, we have to rely on fewer people to make that program work.
This fewer people common theme is a little bit concerning. That's what I'm hearing. Greg, Sebastian, Brian, chime in. Let's just
Yeah.
open it up. And
Yeah, I got three things, a little different than the rest of you. Yeah, manpower is a very important thing. But at the core, the fundamentals are severely lacking in most manufacturing, reliability, engineering, right? People don't do the fundamentals well. They don't know how to commission machines. They don't know how to design machines for the appropriate capacity, environments, and contexts, right? So we're talking about, in my opinion, we're talking about secondary things. And in reality, reliability is inherent to the design of a machine. If we design machines correctly for their application, their capacity, their throughput, all these things, then maintenance becomes lesser, right? Maintenance is a byproduct of a designed component or system. Another thing is the leadership aspect, right? We have to have active and engaged leadership to drive fundamental excellence and change at the shop floor. They need to be able to communicate not only with their peers and subordinates, but with the chain of command, right? How do I get influence? How do I get money for these endeavors and all this type of thing? How do I build trust and relationships with my team so that we can have those excellence strategies? But yeah, I mean, manpower is super important, right? We can't do anything without manpower. But at the end of the day, if we are optimizing our resources, designing, commissioning, and running machines to their design context and parameters, we stand a better chance of having highly available machines.
fascinating.
Great. Yeah, I would just add, and I don't, just to say, I mean, I kind of look at it. I want to start with the positive and say, what can we do to create a world where there are fewer maintenance failures, right? Common failures. And I think whether you're strapped for people and resources or you've got a plethora of those, I think the same basic principles are already always going to apply. So, what do we see as three things that we always want to have? Well, we need to have a culture, right? We need to have a culture that is proactive, that is thoughtful, that is wanting to solve problems. So even answering questions as a negative is a way of saying, yeah, we're always looking to blame something. Well, we want a culture that's positive and a can do and a solve problem. Then we want capabilities, right? A second C. We want to make sure that whatever team we have on the ground knows what they're doing, has the tools that they need, and has the knowledge that they need to implement things. And then third, we need communication, right? We need to make sure that teams are actually functioning and working well together. So yeah, I think if there's a culture in place, the right capabilities and communication, doesn't matter if we have a limited team or a large team. I think we should have the building block in place, maybe to be as world class as we can be. And so that's where we would say, obviously, when those things are not in place, culture, capability of communication, that's where we start to see problems and breakdowns.
Let me bring Greg in here. Greg, I feel like you may have a different perspective or an enhanced view of this. So, any comments on your end, Greg?
I would certainly like to say that everyone's thoughts on that is spot on across the board. That what we're seeing in this industry, everyone touched on every bit of it. I think some of the things too, in additional from an end user's perspective, if I may step back as a former end user, is a lot of the tribal knowledge in our workplaces has left. And if they haven't left, they're about to leave. And what are we able to replace that tribal knowledge with? And the pool we will find is very, very small, very limited. So that being said, it's incumbent upon us as the outsiders to really be there to help supply those needs. We have some brilliant young engineers that have graduated from school, but at the end of the day, they step into these plants and refineries and such, and they have very little knowledge about the day-to-day activity, the hands-on. The book can tell you so much, but at the end of the day, it's those 30 or 40 years of experience that tribal knowledge I refer to that left, that could walk out there and immediately assess the problem and come up with a solution. We don't have that luxury anymore that we used to have. So that being said, I see that our customers are faced, even us are faced with a secondary issue, which is most of these plants were built back in the 1920s, 1930s, 1940s. This equipment that's in these plants is still there today, and it's being expected to perform in a different process or in a different flow condition, a totally different hydraulic scenario with the same piece of equipment. Even to Adam's point earlier about, or not Adam, but Brian talking about the designs. If if this equipment is not designed properly, then it's going to fail. It's doomed to fail from the beginning. So we've got to take a step back and really look at things such as the pump curve, the current conditions, the efficiency points, and understand fully where is this pump operating at. And we'll find like 9 times out of 10 that these original designs are not going to work as they want them to work. So it's incumbent upon us to step in and come up with engineered solutions across the board to try to help get these pieces of equipment back to where they'll run and cut cost and maintenance cost and predict their failures through predictive maintenance, such as what Ludeca does. And we all have to be those suppliers of that knowledge because it's just not there in the plant anymore.
So let's expand on that, Greg. I had the luxury of going to the Pascagoula Chevron plant, not Port Arthur, but I figured if you knew that one, you would know them. And it is an amazing facility. Can you give a specific example? And what did that look like on the ground when you were there? I mean, as far as obsolete or, it was, anciently installed equipment that, do you have any particular example? Not singling out any one.
No, I mean all the refineries, whether it's Chevron or Exxon Mobil's, it doesn't matter. All of them are faced with the same thing. Their capital expenditure monies are not there like they used to be. So, in order for them to be able to perform certain processes in the plant, they try to do that with the existing equipment they have, and that's multifaceted because it saves cost for new equipment. You don't have any civil changes, which is a major ordeal in an existing refinery. If you go out and start changing out a pump to something larger to meet the conditions you want to run, or maybe even something smaller, now we're looking at base plate modifications. We're looking at piping changes. We're looking at cooler installations, or maybe heat exchanger installation, things of that nature. So they try to do everything they can within the envelope of that piece of equipment that they can. As far as specific examples, there are many that are out there, but numerous ones come out to trying to get more flow and head out of a pump that just won't do it. And what we try to do from a hydro standpoint is go in and look at the current volute, look at the current impeller that's in the pump, and understand more about, can we actually meet with a modification to that existing case and perhaps manufacturing a new impeller, can we get closer to that design that they want to operate without having the pump fail so many times? We are able to offer that. In some cases, the envelope just doesn't allow it. There's just not enough room to get the flow and head that they want. The next issue you run into is if you can get that flow and head out of that piece of equipment, will the existing driver support it from a horsepower standpoint? That's the next issue that you run into. So you have to try to work within the limitations of that motor or that steam turbine, whichever one is driving that piece of equipment. Can it handle that additional hydraulic load? In some cases you can, some cases you can't. There again, you go back to a civil modification. If I have to change that motor, now I've got to change the base plate. So it's a difficult challenge.
Greg, I've seen that in real world where someone tried to change out an existing older pump, and based on horsepower, motor size, and base, they made the change. When they ran the pumps, the head that they were producing was the shutoff head for the pumps. Yeah. So the pumps actually weren't doing anything.
That's right.
To avoid. And I think that's, to your point, all of these older pumps are going to be changed out to newer pumps, and we need to go down into the real grassroots of the design, to Brian's point, and make sure that they are operating for the system, not to replace a pump.
Right. And I think that's the driving factor for some of the new builds that we're seeing in these plants now. We're starting to see a few new units that are being built and coming online, and that's to be able to increase some of these processes that otherwise they just wouldn't be able to accomplish.
Okay, opening it up to the rest of the team here. Anybody have a specific example? What did it look like on the ground in your world? Anybody else? Brian, it looked like you wanted to say something. That's why I was asking.
No, I mean, I guess, a lot of people here have, explained they've done the work, they've been in the plants and all, and I always look, that's always like my first reference point when I think about maintenance and reliability, right? I don't look at it from, people with this degree and this and that, right? You look at, your shop floor, in the facilities, the pulse of that is really going to tell you a lot, right? I mean, I've gone and done consulting for large companies and didn't talk to anybody but operators at a machine, and you can walk into a facility and you can just see visually the type of culture or the type of organization that is running and operating these machines or this business, just the way that people carry themselves and conduct themselves and the communication that flows between maintainer and operator and quality and just keeping it pump specific. Like, pumps are very robust, simple machines. We kill them by the ancillary things that are associated with them. We don't have the appropriate suction runs. We don't have the proper pipe sizing. We don't have, the types of elbows and reducers that are concentric and, all these types of things. So, or we run them with a VFD and we don't even understand the VFD characteristics of the motor, right? So we're causing cavitation. We're causing all these issues. We're causing bearing defects. But pumps in general are such reliable machines. It's just that we pick them ad hoc or generalized, and we say, "Oh, it's a pump. Pfft, it can pump anything. Go ahead, bolt it to the floor." Right? So, like, I always go back to the super simple things. Like, you guys know this. There's just so many. The biggest impact is the low hanging fruit, right? It's the 80/20 rule. And those basic things are what kill you and what make you.
Good point, Brian.
It really is. It kind of brings me to the next question that I was going to ask. You almost served it up on a silver platter here, Brian. What proactive strategies have you seen deliver the biggest impact in improving equipment reliability and reducing downtime?
Planning and scheduling. No doubt.
Yeah.
Design machines correctly, have active leadership, plan and schedule your work, and in some cases, or most cases, partner with a contractor who understands the equipment that can provide you with technical expertise. But planning and scheduling from a maintenance management standpoint is the biggest bang for your buck, assuming you have the appropriate resources to do so. But planning and scheduling is my answer for that.
Let's hear from Paul, Adam, and Sebastian in that order. Paul, what about you?
I think, I agree 100% with Brian. Like, the machine itself is a simple device. I mean, a pump is one of the simplest devices that you're gonna find out there, and for the most part, they work. There are not a lot of poorly designed machines or unreliable machines. It is 100% surrounding how do you treat it. I mean, number one, how are you applying it in the process? And I think Greg had some good points about how these plants have morphed over the years from the time they were built to the time they are now. So in a lot of cases, it's not doing what it was originally designed to do. And sometimes these plants have had expansions or changes to the process too, and all that goes into it. I mean, really, I don't know that I've got all the great answers, but it seems like if people were really sort of doing a survey periodically where they looked at any time that their process has changed, and then look at, is this the right equipment for it, and or is there a different way that we could utilize this equipment that would help it live in the application? I think that could go an awful long way towards making all of these systems more reliable because I mean, we've all seen it. It's vibration, it's cavitation, it's running way far left, way far right on the curve. These are all the things that destroy pumps, not bad bearings or bad mechanical seals or things like that. It's it's mostly it's mostly misapplication or misuse.
Adam, it's perfect
Okay.
opportunity for you here,
Not
right?
really.
Ready?
Um, yeah, a little bit. So I'm gonna go back a little bit to Brian and Sebastian's point earlier, and I feel like to establish a good proactive strategy, you first have to spread a culture of reliability, right? So that everybody can buy into uh, doing things right, as I was saying earlier, doing things right the first time. So I think the best way or the best proactive strategy in my opinion, is properly written standard operating procedures. If you can plan and schedule, and that's going to be great, and it's going to save you time. But if you don't have a way for that young millwright that's coming in new to the plant or apprentice to, you send them out to do a job. If he doesn't have a standard way of doing things, he'll introduce a defect into, Brian's point of the machine should last. If it was properly maintained, it should last or maybe exceed its life expectancy, right? So anytime that we have to perform maintenance on that machine, we need to know what the standard procedure is so that we all do the job the same way every time. Obviously, training the personnel and understanding why the machine operates a certain way or why we operated as that pump at a certain capacity instead of this other percentage, then it helps them understand and appreciate the job a little bit better, and it will also solve the problem of being short-staffed or that transfer of knowledge from the retiring generation to the new generation coming in.
Sebastian, you're up.
Sure. Well, our company obviously specializes in root cause analysis. So unfortunately, we're a little bit of a one-track mind when it comes to this, but agree with Brian that planning and scheduling is just foundational to everything in a maintenance program. But of course, RCA is what's going to make that strategy smarter over time. Just kind of think real world analogy. Planning and scheduling is like putting things on your calendar. Like I want to get to the gym. But as I've unfortunately started to learn all too well, it's not just getting to the gym, but figuring out why my shoulder always hurts when I go there. So we need kind of both. We need to get there. We need to figure out what's going wrong and fix that. So we need to kind of get smarter. And so, when we talk about proactive strategies in our world, and again, I'm sure every one of us with the different tool sets we provide, it's going to be a little bit contextually different. But for us with RCAs, we always say to folks, start with just doing a quantity of RCAs. Don't worry about how good they are yet. Don't worry about how perfect they are. Just start doing something, get your team used to that. Then over time, you want to build consistency, right? Of course, once you're doing something, it's not good enough just to do it. Again, back to the gym analogy. Once I'm there, now I want to start using it correctly, right? So you want to start doing it consistently and doing it right. We then find kind of a shared knowledge base is very valuable, just to make sure that as people come and go in an organization, that there is a shared knowledge base that if you solved a problem once in the past, you learned lessons once in the past, you want to be able to pass those on to future workers, even if you don't know who those folks are. You don't want to have this brain drain constantly in your organization. You need to have that knowledge base. And another thing we always find is super helpful is connecting, at least again in our world, when we do RCAs, we want to connect those to KPIs. So we don't want problems to be solved or solutions to be devised that aren't somehow connected to what's the big picture. What are we really solving for as an organization? If we're trying to do things better, we want to know and connect that to what those metrics are that help us see that they're getting better. So those are some of the proactive strategies that we try to encourage people. And again, we see it as if you're being proactive in your planning and scheduling, you definitely want to be proactive in, whenever you have a deviation from that or a problem that comes up within that.
Let's start with Rob, maybe Jake, if you're welcome to chime in. Any other additional comments? up for grabs here. But anybody have anything else to add?
Yeah, I think that the planning is important. I think we've talked about culture. I think it starts with the culture. I think having people in the facility, in the maintenance realm, who understand the impact of that equipment on the overall organization and care about that. I think to our talk about less people available means that in the planning process, you may have to layer between organic maintenance and third party maintenance, right? And make sure that the third party maintenance is there in a culture, fits the culture that you're in, that there's integration there. There may be equipment that's highly critical that needs to be maintained organically just because of the response and the value to the process. And there might be others that run to failure but are swapped out by a third party. And so I think having that management style of being able to layer both organic, third party systems is important to build an entire program and looking at the criticality of each of the equipment and making sure everyone is aware of that through education.
Excellent. This has been quite interesting so far. I want to shift to technology. I want to start it off with Greg, and then Greg, feel free to toss it to whomever you wish after this. But and I'm asking you specifically because I know a little bit about hydro. How has technology, such as predictive maintenance tools, remote monitoring, how has that changed the way your team approaches reliability? That's just perfectly presented to you. So take the ball and run.
You pretty much said it all right there, Vince. No, I can honestly say that having the condition monitoring as a segue into that, a lot of the plants out there have their own condition monitoring groups that have routine route-based management, if you will, where they go out and do their own data collection periodically. Some of the critical pieces of equipment have condition monitoring on those that, like compressors, big critical pieces of equipment. What we try to target is those that are not being monitored 24 hours a day with some of that condition monitoring to try to help keep an eye on some of these different processes so that we can be more proactive in helping them schedule their maintenance and their downtime. Again, it goes back to what I said earlier that some of the tribal knowledge out there is not there, so they don't have in the manpower. They don't have the luxury of just being able to do everything they once were able to do. They are smaller than what they are. So we do utilize the condition monitoring is one avenue in to try to monitor this equipment, help them predict their failures. We also have our hydro reliability services where we're able to actually go in as well and do flow testing in the plants themselves to be able to help them determine if the pieces of equipment are operating efficiently, and if so, if not, rather, what are we going to do to correct that? And at that time, we can offer up suggestions and engineered solutions. Ultimately, it's up to them to promote that to their powers and be able to get the funding to make those changes. Another area that we are able to do is supply training to help train some of these folks through training aspects to help them recognize potential failures up front to be able to start noticing whenever these pumps are going to fail. So many times these pieces of equipment fail, and it's just the unplanned outages is so costly to these customers. So we really try to focus on getting in upfront and helping them to predict that ahead of time. Again, either through training, reliability services, condition monitoring, to try to help get them to understand the condition and the health the equipment is in. Adam, I've always been a fan of Ludeca. When I was an end user, we used them as well. So I would toss this over to you to get your thoughts as well on that.
Yeah, I appreciate it, man. Yeah, you mentioned condition monitoring, and I feel like condition monitoring is going to shift, or whoever's implementing condition monitoring in their site will shift into the planned downtime realm, right? You're starting to catch things a little earlier. And there's been a shift in the last at least 15, maybe 20 years of more vibration data collection in the industry, right? And now we're starting to see a shift into the wireless. And, Vince, you mentioned remotes, the wireless sensors, right? And to me, it's all about time efficiency or working more efficiently with the time that you're allotted throughout the day for your maintenance tasks. So having something like a wireless sensor can help you still track a machine that's in a remote location where you have to drive
Correct.
a couple of miles, maybe more than a couple of miles, right, to get to see how that pump is performing. That might be part of your route. It might take you half day just to see, a couple of pumps. Now you can kind of see that remotely from your desk, or even entering hazardous areas in the plant that don't that you shouldn't. You might need a permit and all that. Now you have daily access to that data. And you're starting to see also now ultrasonic imagers pop up throughout the industry, which also make it more efficient for you to pick up failures or catch them early. Do surveys, electrical inspection, things like that, or in mechanical surveys, finding leaks. You can catch them a little sooner just by kind of pointing and shoot and recording it. So I would say those are the technologies that you're starting to see now in the industry that can kind of help in that direction.
Yeah, to your point on the offsite, that's probably very important when you start looking at how much equipment is out there on the pipelines that are unmanned pipelines, more
Correct.
so now than ever. Being able to go with the wireless condition monitoring like that, we're able to start watching this equipment, especially when they start doing process changes, going from an ethylene to a diesel, or the specific gravity changes in some of the products that are running down these pipelines can set off vibration alarms, and they otherwise wouldn't know it and potentially tear a piece of equipment up. So having the wireless condition monitoring like we offer and others offer is a big step in the right direction for future predictive maintenance.
Let me jump in here. I've heard the term tribal knowledge passed around quite a bit. Uh, Selfish promo here. I do a little thing called Lunch and Learn with Vince. I don't know if you guys can see that, but that's what I do on the Empowering Pumps website. And I just wanted to share that with you for just a brief second. And I want to tee this up for Sebastian. Sebastian, I know that you're going to have to head out soon. So, what tools specifically that your company do you offer for RCA? Do you have recorded lessons, or this is your chance to tell me a little bit more about you, your company, and what tools are used for um, uh, RCA, I believe you called it.
Yeah, so it's great. Yeah, so we do all the above. I mean, for our company, again, we focus very much on root cause analysis. Some call it, slightly different names, but our CFA, whatever you want to call it. But it's fundamentally problem solving related to getting to those most impactful measures. So as a company, we are committed to a few things. We do give a lot of content away for free. So on our website, reliability.com, you can go and watch a training on how to do 5 whys, how to do a fishbone, and just learn the basics of doing RCAs. There's another talk on just thinking strategically about how an RCA fits within an overall reliability program and kind of where it fits in that journey, and when you should invest in it. So we give a lot of that away for free, but also, of course, we've got some courses that you can subscribe to digitally, and we also do some private trainings. So there's a lot on that side that we provide. Our kind of our flagship product has actually become our software platform. It's called Easy RCA because we think it's an easy way to do RCAs. So we so named it that because when we designed that software, we talked to a lot of people, and RCAs were almost like a 4-letter word, right? People just hated doing them. It was like when you were in school and your teacher made you write a book report or something. It was just like the thing I really don't want to do. And it was really interesting as we started talking to people. What we found is that they didn't dislike all aspects of an RCA. What they disliked were the book report like aspects of an RCA. So they didn't like, so starting positively, what they loved was kind of the problem solving in a room with other smart people thinking outside the box, thinking creatively about a problem that, of all the technologies and tools that we have, still wasn't being solved through that. So it required some intuition, some expertise, and they love being in the room with sticky notes, problem solving that. And so we said, you know what, we can actually create an experience that is very similar to that digitally, so that the primary thing you're doing in doing an RCA is that problem solving that you really like. And that's only gotten better and better with AI being added to our solution, right? So almost all aspects of an RCA that are very tedious, right? That kind of bring about blockages. Like, I'm a little stuck. I can't think of another reason why something might have happened, or I'm new and I don't know a process. All those things are now really empowered through AI. The final report, creating tasks, like a lot of these things that people didn't like. And what it does is it actually doesn't take power away from the reliability engineer. It actually empowers them, right? It gives them a lot of confidence in our skills are really valuable, because now we're doing the things we went to school for, the real problem solving, the real insights, looking at data from different sources, thinking creatively, asking questions, and all that tedium is taken away. So we see technology and is really helping, the RCA process. So just to answer your question, kind of both questions, what do we do and what does the technology do? Our whole thing is like, we just help teams do RCAs with excellence, and we absolutely think technology is a real component of it. But I always tell people this story. When I was growing up, I used to love playing tennis, and I played tennis with my grandfather, and I was in my athletic prime, right? And my grandfather was a lot older. He had a tiny wooden racket, and I had the latest, greatest big head graphite racket. And he would just demolish me every time we would play tennis, right? Why is that? I had better technology, I had better tools, right? How could he beat me? Well, the answer was he knew what he was doing. He knew how to wield a quote inferior tool despite all that I had. And so whenever we talk about technology, we just like to have people say, like, you can have the most advanced, sophisticated technology in the world, but if you don't have the people who know what they're doing, it's not going to make a difference. However, put that incredible technology in the hands of people who know what they're doing, and all of a sudden you're going to have dramatic improvement. So that's again what we aim to do as a company: put technology around root cause analysis in people's hands, and then sort of get out of their way so they can solve problems and make a difference.
That's a great story about your grandfather. The visual that it paints is awesome. I mean, I love that kind of thing. I'm big on stories, so if any of you guys have any other stories to relate, that's a perfect time to just tee it up. And again, I want to thank you, Sebastian, for your
Yeah.
insight time.
And
I
I'll
do know.
let's tell one more story. You asked for real world examples. So we had
Love
a mining, and this is again using our tool, but it could have used anyone's tool. So we had a mining company avoid a $500,000 shutdown because they recognized, at one site the team started seeing a conveyor belt kind of acting up. It would stop here and there, but nothing major. And so they started investigating. Instead of waiting for it to fail, they said, let's do a problem solving exercise. Let's do a root cause analysis. And what they found out was that the type of ore that they were processing had changed a little bit. Not a lot, but just a little bit. And so it was kind of kicking up more dust and heat than usual. And that combo was kind of burning through lubricator faster than expected. And so by doing this problem, by being inquisitive in the first place, by doing a problem solving exercise, they realized um, how they had to adjust, how often they lubricated, what type of grease they were using. They added more sensors so that they could keep an eye on it, and they solved that problem before bringing about a work stoppage. So again, instead of shutting down a plant with a $500,000 cost, just through thinking proactively, by putting some thought process into it, and then using data from all these great technologies, they were able to solve that problem. So I love stories like that too, where you see real world $500,000 problems being solved by folks in the field, just doing, I think, what they're good at and what they love doing. And by freeing them up to be able to do that, I think we can have a lot more solutions like that in place.
Thank you. That's awesome. And again, thanks for your time. I know
Yeah.
if you cut out feel free to drop off, but I want to thank you again for your
And
time.
thank you for having me. I really appreciate it. And I'm so thankful to be a part of the conversation.
Thank you. Gentlemen, this is your opportunity. Does anyone else have a story, an analogy, an example? This is a perfect example. Rob, got anything?
Yeah, no, I think, one of the harshest environments that we see and operate in is a wood yard and a pulp and paper mill. So, when you get into it, it's not exactly for pumps, sorry, but you get a bearing housing, and the bearing housing is just full of sawdust, and so everyone wants to lubricate more, but the more they put lubricant in, the more it fails. And so we've been in several conditions where we've had to put an isolator, a seal on a bearing housing that's designed for that environment, and then you put a synthetic oil in it, and you just don't touch it again. And that's sort of sometimes sort of that counterculture, counterintuitive that you need to do is understand the root cause of the failure, what's happening, and then eliminate it. And then you can move forward with your plan. Similarly, in pulp and paper with pulper gearboxes, right? We see that all the time, and it's just a matter of the environment that you're in, the challenges that you have with the equipment operating, right? Shaft movement, axial movement, all of that has to be in play. And how do you monitor it, and when does it get out of place? And so, our goal here is we're in a great position on the piece of equipment right next to the bearing. And so now the question is, what information can we provide that's valuable to maintenance? And that's where we're moving forward.
Excellent. Wow, that's good stuff, guys. Anybody else have a story to share?
Well, I'm sure everybody's got a story to share on this one. I mean, one of my favorites was this actually started off. It was a new piece of equipment, and they had set it up, they started it up, and it had been running for a couple of weeks. And we get a report that, hey, there's a pinhole leak from the case. So it should be a warranty situation. It's like, well, yeah, I mean, I'm surprised because all of these are hydro tested. So I'm really surprised that a pinhole leak would get out. But okay, I guess it sometimes happens. So we replaced the case, and sure enough, 2 weeks later, this one now has a pinhole leak. So I actually traveled there to see what exactly was going on. And when they showed me the unit, I flipped it over, and the cavitation was so bad that in 2 weeks it was eating all the way through the case and creating this pinhole leak. So a wonderful example of even how on a brand new piece of equipment, how the condition can dramatically influence how reliable that system is. So they had to make some significant changes to their process in order to prevent that. But after that, then there were no more problems.
What was the item, the fluid, and
Well, it was a light slurry of trying to think of it. It was it's like sodium hydroxide or something like that. And what was going on was that they didn't have enough velocity in their inlet, and so it was starting, like they were dropping out of suspension, and then it was slowly but surely plugging off, and then they would start the pump, and it would cavitate, and then it would eat through in very short order. So they had to really do some significant piping changes and really had to kind of on the fly re-engineer that system so that they wouldn't have that same problem.
This brings me to an example that I was talking to a water wastewater facility treatment plant, and they were going through equipment, but they couldn't understand why. They didn't understand what the deal was until they started to look at what was going on at night when things were pretty much automated and working. That was when a particular factory would they would do a wash down and put out hot water with bubbles and soapy fluids. And it would happen around midnight. And no one was there to see it, but it changed the characteristic of the pumps at during that period. And over time, it was the cause of, in other words, the pumps were fine during the day, but during this massive washdown of hot water and soap, it would change the characteristic of the pump, and it actually was causing problems. They didn't realize that this was happening under the cover of darkness, if you will. So it was kind of an interesting, example that sometimes you have to kind of drop back and look or go on site like you did. Interesting stuff.
Yeah, Vince, I think going on site is so important. I was in a situation, 5-year-old plastics plant, 5 years old, cavitating their impellers on their pumps, and to where it looked like Swiss cheese when they were pulling the impellers out. Went on site. They had 5 pumps in parallel, and the last 2 pumps, with the distribution coming from the far right, coming all the way down, the last 2 pumps on the left were cavitating. You could hear it. You're just running. As we're walking around, I noticed a shadow, an indention on the floor. I had to ask, well, what's this indention? You've only been here 5 years. What was here? Well, that was a water tank. Really? That was a water tank. What is the water tank that you removed? Yeah, we're just making more space. We didn't think we needed it. The cooling tower is just on the other side of the wall, and so the pumps can pull from the cooling tower through the pumps. So, well, how tall was that water tank?
Right.
Well, it was 12 feet tall. It was a big water tank. Well, how tall is the water? I mean, where's the water level at your cooling tower? It's right at about 5 feet. Okay. Did you repipe? Yeah, we repiped from the right. Our pump guy said it wouldn't be a problem. Well, ultimately, when you pull the pump curve out, right, their suction curve for those pumps was a 10-foot water level, not a 5-foot water level. And when they repiped, all of the pumps prior to the last 2 were taking all the water. So the last 2 were being starved. And so sometimes I hate the word re-engineering. Sometimes people can re-engineer themselves right into a problem.
Wow.
That's a good point.
Sorry?
No, that was a good point. That's a good point. I do have a story. I kind of wanted to come back to a point that Brian had made earlier about, planning and scheduling, and I have a story regarding that. When we get hired to go on site, is usually the machine is already off, right? To do, for example, an alignment. And so in this case, it was a boiler feed pump, okay, critical, as you know, critical piece of machinery, and a plant. It was a gearbox failure, and they hired us to go and oversee the alignment. So I go in and take our as found readings for that gearbox to pump alignment and gearbox to motor alignment. We're able to adjust the gearbox, and we have to adjust the motor at that point. I said, all right, we need to lift this guy up a certain amount. I can't remember exactly the amount. I said, all right, let's get the shims out. Well, we got to order the shims. I said, what do you mean? Yeah, there's these shims are special. They're E-shaped. Okay, so we have to order the shims that we need. Okay, so how long is that going to take? Well, it might take a day and a half. So, proper planning saves, thousands of dollars and makes or diminishes production delays, or, time that you can get this equipment up and running. And, Brian was making up that point earlier, it kind of triggered that time. And it's happened so many times, just not having the proper tools, the kit to be already complete with everything you're going to need, shim type, wrench sizes, and all that kind of stuff, just to kind of, for us to do the work efficiently. I think if we start doing something like that, then we can move into working reliably and working more efficiently.
Yeah, Adam, I think there's a misconception when we talk about planning and scheduling. People think it's just, this is the work you're doing and this is when you're going to do it. No, that's not
Right.
what it is. proper planning and scheduling is spare parts allocation and management, labor and manpower capacity and management, contractor capacity and management, production, safety, and quality schedules and constraints alignment. There's so many things that go into that, right? And as you said, if you're properly planning and scheduling work, you're kitting parts. You're
Right.
kitting service parts. You're kitting wearable items. So those E-shaped shims, if you're planned out your commissioning or your realignment of said whatever, you would assume
Correct.
that
Correct.
that those things were accounted for in your planning and scheduling process. But keeping it on the topic of technology, technology to me is an enabler. It's not a end all be all. In my opinion, it's an enablement of your fundamental excellence. You can put sensors on every single thing and it can be the greatest thing in the world and it'll tell you blah, 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 blah. But at the end of the day, if a technician or a person arriving at that whatever doesn't understand what they're doing or how to do it, or doesn't understand the bigger picture, the priorities of the business, whatever, you fail, right? There's going to be problems. You're increasing variability. And as you guys know, us as humans, we are the biggest variable in the maintenance and reliability department because we like to mess with things and we mess with things and we don't know what we're doing, right? Um, there's been many occasions where I've gone and done site evaluations and people have sensors and whatever all over everything, and no one knows how to interpret any of that data. And the reason I'm saying that, because I would argue it's more important on the partner that you choose to do condition monitoring with, more so than the technology that you're using. Granted, there are specifics where you need very special technology. I totally understand that. But there's so many companies nowadays that get on the IoT industry 4.0, all this bullshit, whatever, and they're selling you sensors and going, see you later. And then you have people putting sensors on rotating shafts. You have people not commissioning and baselining vibration. You have people not, no commissioning process, no baseline assessments, no nothing. And they get these sensors and they're like, why does this gearbox keep failing? This sensor never went off. It's not telling us anything. Right. So I believe that the technology enables, but it will enable poor processes and it will enable good processes. And if you have a strong partner, Ludeka, you guys have been in space a long time. I apologize. I don't know anybody else really. I apologize for that. But if you partner with the appropriate company that will go on site, with me, when I was a maintenance manager and director of maintenance and reliability, if I was trying to buy a service or product and they told me that they didn't come on site, you're automatically off the list. It is non-negotiable. We need the expertise to come, train, show our team the do's and don'ts, help us write those tasks and those preventive and corrective strategies. Like it's non-negotiable. Just everybody listening, be wary of people who sell you things and disappear, or
Mhm.
sell you things and then say, "Oh, it's fine. Just stick it right here and then just watch the data. It'll all be magic." Don't do that.
Wow.
Yeah, Brian, our customer interviews with executives and management say that it's almost gotten to a point where there's too much noise,
100%.
right? That all the data is just noise.
Just all it's all nonsense. No one knows. People want data. They don't know what to do with it. And if they do know
Correct.
what to do with it, they have so much of it, they can't discern what's important and what's
Right.
not.
That was a good chunk of information right there and heartfelt too. So I appreciate the candor. I appreciate all the examples and the thought process. In the end of the day, this really is quite compelling. It has a lot to do with the the intention of the equipment from a top-down perspective. Is it the right equipment for the job? And then do I have things in place to continue to maintain that equipment in a scheduled, systematic way? Or am I just slapping a motor and a pump on and walking away and hoping that that'll work? So I do value what you were saying to start off with. It's quite interesting that, having going at it with intentions of saying, look, just because they've done this since the 1920s, maybe we need to look at what the application is and how we can really increase the efficiencies by making changes. So it's good stuff. So we're coming down the home stretch here. Paul, do you have anything to add? Um, Anybody else have anything to add before we kind of move towards the final questions?
No, I mean, in our case, we get asked sometimes for equipment monitoring or at least the provision for there to be monitoring. We don't necessarily get involved so much in that end of things. Really, we're an equipment manufacturer, so we really see it sort of either kind of on the very preparation end, like we want to be able to monitor this equipment, or oh, this thing has already failed. Now we need to either replace it or get the spare parts or whatever. And can you have them here tomorrow, kind of thing. Um, so we sort of see the downstream effects of a lot of what these guys are talking about.
Yeah, I mean, I on a personal note, I've encountered some issues. For example, Rob, you mentioned the lumber mill. Living here in Alabama, wood and pulp is a pretty big product here. Um, I personally had an issue just happened the other day with drywall being cut and sanded and all this kind of stuff, creating dust, and a probably a 30 or 40-year-old motor and fan mechanism that's been working perfectly. And all I did was go up to the fan and measure the diameter of the fan, and the next thing you know, the motor's not turning. It's actually, defaulting and stopping. You know what I mean? Like it would it wouldn't turn, and it would just kind of get to that point and then trigger a breaker, you know. And in my humble thought process, I went up in the attic and I sprayed WD-40 down in the motor and on the shaft and flicked the switch and it started to turn again. It was an exhaust fan. But now you got me wondering, did I just create a gooey substance that's just going to cause burnout much faster? You know what I'm saying? It's a legitimate thing. I mean, it's a action to resolve the immediate issue, but am I making it worse because I'm not? Did that make sense? I mean,
Yeah, I think that you did what most people do, and that's react to keep it running, right? Like just to get it to the next step where maybe you can replace it or you can do real maintenance on it, I guess. So we see that a lot, and sometimes that is a strategy, right? Sometimes putting grease in a bearing makes it run longer, but you've just put a band-aid. You've not actually solved the
Mhm.
problem in most cases. But in critical equipment, to be honest, that's sometimes what's required. I think that goes back to some of the tribal knowledge. There are lots of things out in plants that people know. If I do this, I can get another 2 weeks, and so when you lose that, people start to wonder, well, why is this piece of equipment starting to go out so frequently? Because we didn't have the tribal knowledge that you needed to put a couple of ounces in grease in it every 2 weeks to keep it running. So,
It begs the question though, if you're doing root cause analysis and trying to back engineer what happened to begin with, it 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 almost begs the question, do you also have to factor in the fact that someone's just trying to CYA, cover their butt and
That's why, Vince, sorry for interrupting.
yeah, no, please, please.
That's why tasks and procedures that are specified to a failure mode and an outcome are so important. When you write tasks for people to perform during their preventive or corrective maintenance actions, they need to be concise. They need to be telling that person what to do, what to look for, and know what good looks like. And ultimately, you're going to know what bad looks like.
Mhm.
So the reason that's so important is because if you have these things laid out in your CMMS, or maybe you just write them on a piece of doesn't whatever. CMMS is take it out of the equation if you want, right? If you having concise tasks that are step by step in succession, that are pointing out failure modes, that are identifying things and telling you what to do and look for, then you're inherently, as the maintenance department, covering your ass, right? Because you have the work instructions that are structured so the technician to follow and sign off on their work order. So your example, let's just say that we all work in that drywall plant and this one motor's been working beautifully forever, and then all of a sudden it gets hit with a big dose of drywall. Well, our preventive maintenance strategy is already built for that if we've been there, right?
Right.
So we need to be understanding, how does what we are doing now affect or have some sort of impact to what we think we need to do, right? So the idea here is to take away all the like what ifs and I thinks and create that standard task procedure that is followed to the T. And then also you create pass fail sections as well. So if you do inspect something and it does fail your what good looks like or whatever, then you're failing it and you're generating a corrective work order automatically to keep up with those things, right? So you're not just the technicians just go out and wander around the facility and go, oh, this doesn't look right, fail, and then it just disappears into the ether, right? It's keeping track of all those sequential work orders that are associated with that initial issue. But tasks, like I do a whole training free through Upkeep, which is task creation, preventive maintenance task creation, just how to write tasks for your work order system or for whatever. Because I'm sure a lot of you know who've gone into maintenance functions and around the country, PMs look like this. Check belt. Next one. Look at pump. Next one. Is pipe leaking? Like, what is that? What does that mean? Right?
Yeah, different things of different people is what it means.
Yeah, exactly. And you're creating variability. And then the same people will say, we have all these failures, but we do PMs, we do maintenance. Sorry, everybody listening, maintenance does not equate to available machines because
Hmm.
most of the time, maintenance is non-value adding tasks. That's why every task should be addressing or trying to uncover a known or potential failure mode. And if they're not, you're essentially wasting your time. Now, I understand compliance in oil and gas and stuff like where you just have to check stuff regardless of if it provides an outcome. I totally get that. But, there's just a tremendous amount of non-value adding work in our industry, which consequently causes problems for the whole entire department.
Yeah, and
Yes.
I think a large part that kind of comes back to kind of the very first thing we talked about with the reduction in these maintenance crews. Like when I first started going to these plants back in the 90s, they might have 10 guys that were there for, some of them were there for 30 years, some of them were there for 20 years, some of them were there for 10 years. You go back to that same plant today, they're lucky to have 5 maintenance guys, and maybe one of them has been there longer than 2 or 3 years.
Right.
And so when you say, "Oh, hey, check the belt," that guy that had been there for 20 years, he knew exactly what you meant. He knew exactly
Right.
what was likely to fail on it, how to do it. But now without having that sort of knowledge that's being passed down, like you have to record it. You have to be specific about what is it that we're trying to check, since we don't have that guy that already knows because he's checked that piece of equipment for the last 20 years.
Your CMMS is an inherent historian. If you catch those people prior to their exodus or leaving or whatever, and you sit down with them and you have them help you write those tasks, now you've captured that knowledge that other people now can leverage into the future. And it may change, right? You may have to modify as you go along, but a CMMS is a historian, not just for assets and work, but for knowledge. And that's the main thing I'm talking about is that's why I said in the beginning, active leadership is going out there and building those relationships and driving those conversations to better the overall organization and the organization's business goals, which come down to, like you said, knowledge.
That really, again, shameless plug, but that really summarizes what my intentions were with the Lunch and Learn with Vince recordings, was to take various industries and record this tribal knowledge. It's not self-promotional for me, but it truly is. If you have some advice, if to give somebody 5, 10, 15 years from now, when we're gone from the industry completely, but somebody could pick up some nugget of information that would make their life easier and prevent making the same mistake that you did years ago, um, I've done something. So I get what you're saying about the CMS, and that's more internal to the organization. I'm just grabbing people from the seal industry and from the hydro ink industry has done some lunch and learns with me. And, that's the kind of thing that I'm trying to do is harvest it and put it on one platform where you can have sort of this montage of different industries and just give me your best advice. So, with that comment, I'd like to kind of work our way towards the end of this discussion group by just asking, what's the one piece of advice that you would leave the maintenance professional? That's the first part of it. So let's start with that question, and then I've got one more to wrap up. But each of you, if you would, what's the one piece of advice you'd leave with maintenance professionals? I'm talking they're on your level or above. What would that be? And let's just start with Brian and then work our way to Rob and go on down.
All right. My advice would be to build relationships, build interdepartmental relationships and relationships with your suppliers and contractors, and ensure that there is a understood and equal playing field. And in most organizations that have maintenance operations, there's generally a strife between maintenance and operations. They believe that operations just breaks the machines and maintenance fixes the machines. But in reality, they are mutual business drivers, and there must be relationships between all interdepartmental people, operations, quality, safety, all of that. They should all be your best friends, and you should all be working towards the common business goals and have those relationships. You would be surprised at how many things you can get out of the way that originally would be stifling you if you just build the correct relationships. Somebody
I would
jump
have to, I totally agree with Brian on that, but I'm going to make a really simple comment here. If I was looking at an individual in maintenance in a facility, read the manuals. Like, get familiar with the equipment you're working with. And everyone has the manuals, but oddly enough, very few have actually read through the manual unless there's a problem. You can learn a lot of information from the manual. You can become a subject matter expert by reading a manual.
Mm.
Mhm. I was going to say something else, but Brian brought up a good point. You know, bu- Maintenance. If you're in maintenance, there's already an inherent. I don't want to say hate because it's a strong word, right? But some resentment that I have to bring my machine down so that you can do your job, right? We have to stop production so that you can do your job. We have to stop sales and stop revenue so that you can do your job. But if you don't do your job, then we're down for a longer period of time, right? And so building relationships, Brian brings up a good point. And if you're in maintenance, have a good relationship with operations, right? And so that you both, make sure the operations is doing their job by operating the machine within its capacity and, doing proper procedures of shutdown and startups and all that, but also understanding as to why maintenance needs to access the machine, right? Where I need you to shut it down for this short amount of time so that I can, you know, do this task to it, this proper maintenance to it. So that in the long run, it kind of it stays running for a longer period of time. You increase that mean time between failure. But what I was going to say earlier is, to me, as a maintenance professional, is it a little bit piggybacking off of Rob is learn why things are done a certain way. Uh, why does that machine operate a certain way? I'm addicted to knowledge. I always want to learn and improve myself. Uh, you know, so getting trained, getting certifications, and learn about the process that you're in, I think goes a long way.
So, Paul, if I may, Kerflow out of Texas makes all kinds of great products and aftermarket products. If you were to give some advice, what's the one piece of advice you'd leave with the maintenance professionals that are utilizing your equipment, your products?
I would say, I mean, I would say sort of take a step back and keep an eye on the big picture. Many times in maintenance, especially, you get hyper focused on what's urgent today and what are you trying to fix. Like many times, I'll go and we'll talk to the maintenance manager at a plant, and I'll ask him like, well, what pump problems do you have? And invariably they will say, well, we don't really have any pump problems. And then you'll go and you'll start to look at the process and look at some equipment, and you'll see that they've got three spares sitting there. It's like, wow, why have you got so many of these? Oh, well, because this pump, we have to replace it every month. And you say, well, I thought you just told me you didn't have any pump problems. And it's like, but in his mind, it's not a problem because he's got his spares. So when the pump fails, he can replace it. He sends it out, it gets rebuilt. So it's not a problem. But that's not
That's the
really
norm. That's the
solving,
norm for
solving the
them. Yeah.
problem, right? Yeah. So I would say always keep some eye on the big picture. What is it we're trying to accomplish here? How can you solve a long-term problem rather than only looking at what do I have to get done today? What do I have to get done this week?
Yeah, that's interesting. Adam, you were about to say something that's their norm.
Correct. Yeah. For people like that, yeah. It fails every 3 months. We have the guy that's the best at replacing that pump. He can do it under 30 minutes. It's not a problem. We keep going. For some people, that's the norm instead of, why is it failing? Why is that happening every 3 months if it's meant to be running for 6 years or
Yeah.
whatever, however.
Yeah, we don't make a single pump that it should fail in 3 months or 6 months or in a year. Like there's none of them that are designed that way. If they're failing, even if they even last less than about 5 years, I would say you should really think about taking a look at it and seeing what's failing and why is it failing.
Yeah. Greg, you've been quiet for a bit. How about you? If I could, just one piece of advice you'd leave with maintenance professionals as it relates to Hydro Inc.
One of the biggest things, Vince, that we really want to push, and it kind of echoes where Brian started a while ago, and that's having those relationships. It's imperative that the relationships between maintenance and operations within the plant and amongst each other is important. But as a third party supplier of services out here, I want to build that relationship with that plant manager or with that maintenance manager as well to assure him that he's not alone in this boat. We've been there, we've done that. We've seen the problems that you're faced with. Tell me what's keeping you up at night and let me see if I can provide a solution where it makes sense so that you can get the rest you need. And that's kind of the relationship approach that I take, is to let them know that we as Hydro have the opportunity to be able to supply those solutions where it makes sense to keep that equipment running, and that building that relationship long term will be better for both parties, both sides of this business.
This is fascinating. I have to tell you, I don't want to go down the rabbit trail here as we near the end of this summit, but where I was thinking more nuts and bolts, the overriding theme here is humans, people, how we deal with each other. And uh, maybe it's my fault, but I thought we were going to hear more mechanical and again nuts and bolts. But the more I realize, the overriding metaphor here is human interaction, which is
Most problems you
still
find are human problems, not mechanical problems. Mechanical problems are a byproduct of human problems.
yeah.
I think Brian hit the
Yeah.
nail on the head with that. I mean, he mentioned that early on, that, it's inherent that we want to get our hands on something and start messing with it. That's just what we want to do. It comes by nature. But sometimes we're our own worst enemy.
But
Maintenance,
then
maintenance is
again,
a byproduct, right, Vince? I mean, maintenance is a byproduct of the design or commissioning of a machine.
Sure.
You literally decide how much you're going to fool with that machine when you select it from a supplier and its design context, whether you're going to run it in a certain environment or capacity or context, you're deciding in those moments how often you're going to fool with that thing. And you can decide to do all the right things up front and not fool with it very much at all. Or you can decide to do, which most people do the wrong things and then mess with it a whole lot and then be upset that maintenance isn't solving your reliability and availability problems.
But in addition to that, too, and that's very important, is that those pieces of equipment may have been properly selected back in the beginning, but now
Sure.
they're not. But the requirements of that equipment today is so far off; it's
Sure.
incredible.
Yeah.
So it's inherent that we have to be there to help provide that solution to get it where it needs to be. And one of the additions that we have, besides the being able to monitor that equipment, is the fact that we can have a highly engineered solution for it that we think will get the pump uh, back where it needs to be, and then we can actually test that pump to validate what we're saying we can do with it. So again, I think it goes back to those relationships, Vince, that we have to build that trust and credibility so that they know that this equipment can be brought back to where it needs to be.
We are always in manufacturing and industry, and I hate to say the we, but it is really we, right? We are always willing to trade away tomorrow's reliability for today's production.
Mhm.
Oh yeah,
That's
absolutely. Well put. Well put.
well put. The again, the profound part of this for me personally, my takeaway is that not only is it relationship building as part of this, and to me, it seems like everything I've done in my entire life has been relationship building related. But maybe if we can introspectively look at ourselves and how we do relate to that other person, whether it's maintenance and operations or an engineer to this guy over here. My point is maybe the real challenge is, or the real gift would be the way we can key in on that individual and really relate and really connect on a human level, which is something AI and other you know maintenance type things, connections and vibration technologies. None of that is good without the actual ability to relate to the person. In a way, this has really been quite profound. Yeah. Again, I'm looking for the silver bullet, and it gets down to people and how we relate to one another. Very interesting topic, guys. I feel much better about this summit. I was a little nervous going into it, but I was kind of excited to see where this would go. But in the end, humans and how we relate to one another still are a major key component to this. So thank you all. Anybody have any more parting comments or thoughts here or advice? Because it's open. If not, we're going to wrap it up. And I just can't thank you enough for taking time out of your day so we can chat. So anybody got any final comments?
Yes, I would like to just say I'm thankful and grateful both for the opportunity to participate in this. This is my first time to be part of this Empowering Pumps and Equipment Summit, and thank you for the invitation. I would like to request the potential opportunity to get email addresses for the folks that have been on here, especially Brian and Paul and different ones that are, and even Adam, because they deal with a lot of the same things that Hydro deals with, and perhaps we can bounce some thoughts and ideas off of each other that could help each other. Uh, Even being 64 years of age, I still learn to this day that you don't know everything. So there's some ideas and thoughts that Brian and Paul and Adam have all talked about that I would like to tap into their knowledge a little bit more to see what else I can learn while I'm still in the industry.
Yeah, me too. In fact, I'd like to see if we can just include the all of our emails in
Sure.
the content itself. So, uh, Becca, I think you can make that happen, I would imagine. So, with that, I want to just say thank you and God bless you all. It was really
Yeah.
fantastic. Enjoyed
Thank
it.
Thank
you
you
very
again for the
much.
invite.
Thanks, guys. Appreciate it.
Thank
Thank
you.
you very
So,
much. Look forward to doing it.